This rather broken looking piece of equipment is a very old kind of media player I've got. I pulled it out of storage recently. It's something that I used for a couple of years, or no, actually I used it for exactly a year, and then pretty much on kind of the year mark it died. It's a kind of a network media player, so it'll play media files off the kind of a network storage drive, and it also plays DVDs, and it played DVDs through a regular computer DVD drive. This plugged into the board over here with an ID connector, and it was pretty straightforward. It's about a year after using this, the drive itself failed. It kind of part blew inside of it and kind of released it, kind of load of smoke, and that was the end of that. I did switch part over, and it never quite worked properly again. There were issues with it, so I put it to one side and never really looked at it again. But I've taken a look at it recently and spotted a few oddities. I mean, this device itself is a KISS 1000 media player. It was bought by Linksys a while ago, and they seem to have completely abandoned this range of products. But so there's almost no information out there about these anymore. There are a few issues with it. I mean, if you try and play a media file, it fails after about 10-15 minutes. It'll lock up, maybe stutter, lose the sound, bizarre behaviour, and that is not something that's easy to diagnose, at least not with my kind of skill set. I think it's most likely going to be some kind of low-level hardware issue, potentially causing out some kind of software problem. But there is something that kind of caught my attention elsewhere. When powered on, this is a VFD, vacuum fluorescent display, and it glows in a rather peculiar way. I know the basics about how these operate, and it certainly wasn't right. And so I thought it could have been on its way out, so I wasn't quite sure. But then I spotted a capacitor down here. I'll put that zero in a minute. But the top on the capacitor is kind of blown out, really swelled up. Now these regular electrolytic capacitors have kind of a scoring marks on the top, and this is designed to release pressure. So they do go bad over time, they dry out, the swell expands, certainly if there's heat involved. And so I thought that could be causing problems. And so I took a look at the voltage lines on this, and they were way out. There's a series of voltage rails on here, minus 33 volts, which is for the VFD display. And then there's various kind of 12 volt, 9 volt and 5 volt feeds. Some of them were fine, some of them were kind of almost double what they were supposed to be, which does kind of explain a few things. The display itself is, it was kind of very, very bright. I'll power it on in a moment and see if you can show on camera. But so it's possible that was getting too much power, it was glowing way too brightly, and the overvoltage would explain that. It would also explain the failure in this thing. If more than 12 volts was being pumped down into this device, then one of the devices in here, the chips could have just reached the end of its kind of tether one day and just blew. So that explains why that, I think, is gone. I'm just going to power this up, and hopefully the problems with this display will be visible. I've removed a few parts in this. Obviously the drive's gone, and there's also a wireless adapter which I've removed. It wasn't something I was using, so I thought let's strip out everything that isn't absolutely necessary. So that's going to power up. At the moment on this screen it looks fine for some reason. As soon as it passes its boot sequence, the display seems to go into this bizarre mode. Hopefully that won't take much longer. And so kind of starts its kind of boot up sequence, it tries to kind of connect to network drives, which things. Quite luckily it doesn't seem to complain about there being no optical drive, but here we are now in this mode here. And you can see a lot of these other kind of parts are turned on. So despite not having the right kind of logic signal, voltage across the particular segment, they're still lighting up anyway. And it's very peculiar, that. So I'm going to disconnect this part now and take a closer look at the power supply. So this is the power supply. It's a standalone little unit that kind of plugs onto the main board just through this end connector here. It outputs minus 33 volts, 12 volts, 9 volts, 5 volts, kind of analog and digital rails. It does this through a mix of things. It's got a large a switch mode regulator in the middle, and it's got two linear regulators on the side. These handle a couple of the other voltage rails. I think there's a 5 volts and a 9 volt regulator in there. Kind of looking over this for any signs of obvious damage or failure, which will explain high voltages, is this capacitor here. You might be able to see just this black mark. That's some of the electrolyte inside that's oozed out. And on that profile you can see it's just about bulging out there. If it'll be any better closer to the camera, but you can see, there you go, it's kind of pushing out the top. It's obviously a sign of a bad capacitor in there. Now, the problem is this capacitor is on the output line. It's connected before the inductor, but it's still got another capacitor on the output, and this feeds the main 5 volt line. And it's unusual, so it's not part of the main kind of oscillation circuitry or anything like that. It's just smoothing the output. It's the only reason why, the only thing I can think of that would cause problems with this, or that would allow this capacitor to cause problems coming back in, was that if it wasn't doing its job and letting a very noisy signal exist on the output, so this could quite possibly be kind of causing a lot of interference coming back into the power supply, really kind of screwing up its voltage regulation and then impacting the other rails. I'm just going to power this on, take a look at just some of the voltages, and then try switching out this capacitor with something else and see if that helps. I've got this hooked up now. It's powered up and running. See it on the display there. It's in its dodgy mode. I'm just going to measure the voltage on some of these rails. I'm going to take ground from just one of the grounding pads on the PCB over here, so one of the screws holds it down, for simplicity. This is the main 5 volt rail that the bad capacitor is connected to. Now that's showing 5 volts, but the bad capacitor is on the other inductor side of it, so it is close to the transformer and the rest of the switch mode supply than this reading is. That looks fine as it stands. This is the minus 33 volt feed. As you can see, it's minus 50 volts. This should only be minus 33. This is to give the potential across the 50 display to allow the electrons to kind of get enough energy to jump and illuminate the segments. And the other one, which I believe is bad, is the 12 volt feed for the external drive here, which should be up at the end. Yeah, and that's coming up as 18 volts. So that's 18 volts being fed into the external disk drive, which would certainly explain a failure there. So I've had a brief look at this before, so there's definitely a fault with this, which would certainly explain the display issue, the drive issue, and potentially even the stuttering issue. And this capacitor is the only bad thing about this supply I can see. It is on the good 5 volt rail. 5 volt rail is looking fine. And it is on the output, so it's not part of the kind of brick circuitry, but it is on the inside, and it's quite possible it's not clamping a lot of the oscillations that are going on, this high frequency noise, this side of the output inductor. And so if that's being fed back into the system and screwing up its regulation, it could certainly account for these other bad outputs. And so I'm going to have a go switching this capacitor out. Unfortunately I don't have anything as good as this. It is a I'm going to power this off. It's a pretty low voltage one, I think. Did this earlier. So yeah, it's a 10 volt capacitor. So it's only meant to do 5 volts, so that's kind of within tolerance, correctly. And it's a 2200 microfarad capacitor, so quite a big smoothing one. Now, the best I could find was a small electrolytic, 16 volts, again went within capacity, but it's only 220 microfarads, so it's only 10% of this one, so its ability to regulate supply will be significantly less than this one. But if this capacitor has completely failed, gone kind of open circuits, or even not posing a kind of high resistance to the load, a little bit of capacitance is going to be far better than whatever this is doing to the system. So I'm going to switch this out and take a look. Before I switch out the capacitor, I decided to take a quick look at the kind of voltage range. I'll see what's going on the oscilloscope. And so I've hooked up a probe between the capacitor, basically across the capacitor, and I've achieved that just by attaching to a diode and the heatsink of one of the voltage regulators, which is grounded. And I've got a trace up here. I've used the cursor on the scope just to kind of break out one particular waveform to take a look at it. And we've got a frequency of about 106 kilohertz, the switching frequency in use here, and we've got a voltage on here. We're seeing kind of top to bottom of about 8 volts on here, and I don't know if that is what to be expected or not. I've never really kind of delved too much into the workings of a switch mode power supply, and so it's quite possible about 100 kilohertz switching frequency is normal. But what I'm going to do here is do a before and after, compare these readings to the ones after, and see if there's any difference. I'm hoping that that there will be a noticeable difference, and that it will have fixed the issue that's going on here. It is quite possible that this capacitor is just a red herring, and there's nothing actually going on. It's worthwhile comparing them as I can. It might reveal something else. So I'm going to switch it out now. This is the dead capacitor. I've switched it out with a replacement in there. It's a lot smaller, about only 10% of the original capacity, but it's not faulty, this one. I'm going to plug that back in and see if we can get a difference. Okay, so the device is powering up now. Not seeing anything on the scope. There we go, it's the waveform. And it's significantly different. There's a lot less noise on here. I'm going to alter the cursor here. Right, I've repositioned the cursor. I'm just going to see if I can zoom in a bit here, because the difference is fairly significant. The waveform is pretty uniform. We've got no kind of huge spiking rippling on here. Frequency is 131 kilohertz. It's possible. There's probably more kind of where it's supposed to be. Again, I don't really know if it's meant to be that frequency or not, but there's a definite change there. But what's striking is the voltage range. Before we were dipping about 8 volt fluctuation between practically 0 and up to 8 volts. This time round we're fluctuating between 5.12 and 5.6 volts. It's quite a remarkable difference. And you can imagine if you've got a higher value capacitor in there again, up to where it should be, this ripple will probably be kind of flattened out almost entirely. So it certainly looks like that was the cause of this. Let's look at the display. And the display is working. There's no glowing of any of the other digits that were in use. So it looks like one bad capacitor has been responsible for the power supply issues. I'm going to do a quick check of these voltage rails, but given how everything else is behaving, I expect them to be perfect. The 33 volt rail, or minus 33 volt rail, is showing minus 34 volts. The rail, the good 5 volt rail, is still at 5 volts, which is fine. And the 12 volt rail is showing 12.3. So everything is back to normal there. And yeah, that's there. It's quite impressive to see that such a simple thing there is responsible for all of those problems. I'm going to power this up and see if it's solved the other kind of hardware issues I was having. So I've just tried this out, playing some videos, and unfortunately the problem hasn't been solved. It still locks up after kind of 5, 10, 15 minutes into play, which is a bit annoying. I'm not quite sure what's wrong at this stage. It's possible a piece of hardware has been damaged, it might be a software problem, don't know. It's running a pretty old version of the firmware, so I'm going to try replacing it. I've found a slightly newer version of the firmware on here, and I'm going to try and upgrade. Unfortunately, it's not particularly easy to do an upgrade. It did have an over-the-air option, but the kind of FTP server presumably that was served that out has gone offline, probably many years ago now. So I managed to download an ISO, and that needs to be burned onto a disk and then used in the disk drive to perform the upgrade. I stopped using disks quite some time ago, so this is possibly going to be a slightly tricky thing to do, but hopefully I can find some blank disks and drive somewhere to kind of burn this on, and with any luck that might solve the problem. Either way, it's been an interesting investigation, and I'm pretty pleased that I was able to find a problem with the power supply, identify it and fix it. So either way, I guess I'm happy with this.